Mathematics is astonishing, so rich, so beautiful, so useful. The subtlety and power of math exceeds really any reasonable expectations. But where does math come from? Is new mathematics something we discover, like a planet or an exotic animal? Or is it something we invent, something we create, like a new technology or a symphony or an architectural design? The 19th century mathematician Leopold Kronecker took a firm stand on this issue when he said, "God made the integers, all else is the work of man." We'd probably word that thought differently today, but I agree with Kronecker's key insight that there are aspects of math we create, that we invent, and there are other aspects of math that we discover that in some sense seem to exist independently of whether we're aware of them or whether we even exist. Let's start with Kronecker's integers. An integer is defined as a whole number, 1, 2, 3, but also 0 and negative numbers, -1, -2, -3, and so on. The counting numbers, or so-called natural numbers, are the integers that are greater than 0, 1, 2, 3, 4, and so on. I would argue that these counting numbers themselves are actually invented in the sense that they're abstractions of our specific experiences. We can't just experience threeness by itself. There have to be 3 apples or 3 balloons or 3 something. It's that experience of 3 something that we then abstract to create the concept of threeness. Once we've invented this abstracted concept of counting numbers, then we can go on to discover things about them. One of the first things we discover is that there's an unlimited number of counting numbers. You can just add one more as often as you like to get to the next one and do that without end. We can go on to invent abstracted notions like adding counting numbers, subtracting them, multiplying them, dividing them. But once we've invented division, we discover that sometimes division is complete with nothing left over, as when we divide 6 by 3, for example, and sometimes there is something left over, as when we try to divide 7 by 3, which leaves 1 left over. This discovery then might lead to the invention of what we call prime numbers. You'll recall that prime numbers are natural numbers greater than 1 that can't be divided evenly except by themselves and by 1. You might wonder, though, why in the invention of prime numbers, 1 is left off the list. To be sure, 1 is a counting number that can only be divided evenly by itself and by 1, which is itself. So why doesn't that count as a prime number? Well, the answer is that when the prime numbers were invented, a choice was made. The choice was to leave 1 off the list and start with 2, and the reason for that is it's very convenient. By starting the prime numbers with 2 and not including 1, we get to have what's called the fundamental theorem of arithmetic, which is that any counting number can only be divided into prime numbers one way. One way, that is, aside from rearrangements. The number 20, for example, can be formed by multiplying together 5 times 2 times 2, or a rearrangement like 2 times 5 times 2, but there's no other set of prime numbers that can be multiplied together to give you 20. That's the fundamental theorem of arithmetic. Now, what if we had included 1 on our list of prime numbers? Well, let's give them a new name. Let's call them the Sprime numbers. The Sprime numbers are the prime numbers plus the number 1. We could invent this. I just did, and no one can stop us. But if we use the prime numbers, there's no such thing as the fundamental theorem of arithmetic. We lose that. We can't discover that about the prime numbers because it's not true. With the prime numbers, I can divide 20 into 5 times 2 times 2, like before, but also 5 times 2 times 2 times 1, or 5 times 2 times 2 times 1 times 1, and so on. In fact, there'd be an unlimited number of ways to multiply together prime numbers to get 20. So we made choices when inventing the prime numbers, and then once we'd invented them that way, we can discover things like the fundamental theorem of arithmetic. Here's another thing we can discover about the prime numbers, that there's an unlimited number of them, just like there's an unlimited number of counting numbers. Here's how we can prove there's an unlimited number of prime numbers. Let's say we're kind of new to this business, and the only prime numbers we know about are 2 and 7 and 11. What we can do is take the prime numbers we know about and multiply them together. 2 times 7 times 11, which happens to give us 154. Then, here's the key step. We take 154 and we add one more to it. The resulting number, 155, then, can't be divided evenly by 2, or by 7, or by 11. In any case, if we divide 155 by any of these numbers, we'll have 1 left over. So that means that our number 155 is either a prime number itself, or it contains prime numbers that we don't know about yet. And we can work out that, in fact, there are 2 prime numbers that we've just learned about, which are 5 and 31. It's 5 times 31 that gives us 155. That's 155's unique decomposition into prime numbers. But we could continue this process. We could take the set of prime numbers we know about now, multiply those together, add 1, and again, we would have to be able to discover a new prime number that way. So we invented the prime numbers, but then we discovered things about them. And that's how math goes. We invent a new concept, and then we discover the often amazing true facts about that invention. Let me know in the comments what you think. Does this seem right, that we partially invent mathematics and we partially discover mathematics, or would you think about it a different way?